Good morning. But I think no one is there. They have entered.
It's already open. Yeah. Yes.
No, but it's not coming.
It's
That
a new one.
seal has to be.
It's not, okay. Then it's new one. Huh?
Huh. So good morning.
I just
Just I have adjusted it. Okay. So we will start with the class. With regard to last class, we have discussed about anyone. It is aldehydes and ketones. So we were talking about aldehydes and ketones. Okay. So anyone what we had discussed in the last class? Can any one of you? What we had discussed? Yes, good morning. Good morning everyone. You can send you can type the message. What is that topic? You can message it. So first we have discussed about IUPAC nomenclature, right? Then we were talking about preparation of aldehydes and ketones from alcohol. Very good. So we were talking about preparation of aldehydes and ketones. Very good. Aldehydes and ketones. So from alcohol. ಹಾಗಾದ್ರೆ what is that point? Important point with regard to preparation from the alcohol. So preparation of aldehydes and ketones from primary and secondary alcohol. Okay, fine. Very good. So ಹಾಗಾದ್ರೆ one point we know is tertiary alcohols cannot be used. Tertiary alcohol cannot be used. Why? Because tertiary alcohol it will get converted into unsaturation, that is alkenes. Tertiary alcohols will get converted into alkenes. So that's where it cannot be used, because it will give rise to formation of alkenes. Okay? So that is one point. That is with respect to tertiary alcohols. What is that next point which we have discussed? That is primary alcohols always, or it will be giving rise to aldehydes. Primary alcohols, it will give rise to aldehydes. It will not form the ketones. So that's where another important point. So primary alcohols always it will be converted into aldehydes but not ketones. Next is with respect to secondary alcohol always it will give rise to ketones and no aldehydes. So that's what we have discussed, right? So these points you should remember. So that is tertiary alcohol, they will be converted into alkenes. Primary alcohols, they will be converted into aldehydes, but they cannot be used for the ketones. And when it comes to secondary alcohol, they cannot be used for aldehydes. It will be used for the preparation of the ketones. Which is that process which is involved in the preparation of aldehydes and ketones from alcohol. That process is nothing but, any one of you, which is that process which is involved in the conversion of alcohols to respective aldehydes and ketones. Which is that one? So dehydrogenation, very good. So we can call it as oxidation and dehydrogenation. Oxidation and dehydrogenation. Because during the reaction, when alcohols are getting converted into aldehydes or ketones, naturally that is oxidation process. And since there is a removal of hydrogen, that is also called as oxidation, right? Since there is a removal of hydrogen, it is also considered as dehydrogenation. It is also considered as dehydrogenation. So which are those methods? Which are those methods which will be used? Any one of you? Which are those methods which will be used for this particular preparation? One is by using, which are those methods I am asking? One is by using, we use weak oxidizing agent like chromium trioxide or PCC. Very good. So one is by using chromium trioxide, or we can also use PCC. I am not telling both are same, or option it is, okay? So that's where we have the pyridinium chlorochromate. Pyridinium chlorochromate, that is PCC. Any of these oxidizing agents can be used. What is the speciality? As Krishna has written, they are weak oxidizing agents. Why we have to use weak oxidizing agents? To avoid the formation of carboxylic acids. To avoid the formation of carboxylic acids. So we can use a mild oxidizing agent, as the people have written, or a weak oxidizing agent. Now another one already people have written, that is heating with copper or silver metals. Heating with copper or silver metals. That is another method. So this is what we have discussed in the last class. And same thing it is there in your alcohols topic also. With respect to chemical properties of the alcohol, there people have studied all these things. Fine. So this is what we have discussed in the last class. Okay. So we will move to the next one. That is preparation of aldehydes and ketones. Preparation of aldehydes and ketones from alkenes. These things you people have studied. One of the important reaction in first period, hydrocarbons topic. From alkenes, important for your competitive exam point of view. Board exam, definitely they will not ask the reaction from this part, because this was done in first period. Okay, so preparation from alkenes. How to prepare? That is by using ozone. That is by using ozone. Okay, so that is one of the method where aldehydes or ketones will be synthesized from the alkenes. Hagadre, what are alkenes? That is, all of us will know. Yes, AG, I don't know who is that, but absolutely correct. That is by ozonolysis. Yes, Archit, that is by ozonolysis. Okay, so hagadre, when I am talking about this particular reaction, before that one, Arpit, okay. But here Arpit, Archit. Okay, Arpit, Archit. Okay, fine. So that's where we have the by using ozone. All of both of you are correct. That is by ozonolysis process. That is by ozonolysis process. Because there will be formation of intermediate called as ozonide. Anyway, we will have a discussion. But before that, what are alkanes? They are the unsaturated hydrocarbons having double bond. They are the unsaturated hydrocarbons having double bond. That's where we have the alkanes. And I have taken the example of ethene. I have taken the example of ethene. So this molecule is going to react with ozone. This molecule is going to react with the ozone. Okay? Now, all of us we know that ozone is a oxidizing agent. Right? Ozone is a oxidizing agent. Now they are going to react with the ozone. Now there will be shifting of the double bonds. Double bond will not be there. Pi electrons will be shifted to make the bond with the incoming element which is called as oxygen. So therefore CH2 oxygen CH2. Okay. Now another 2 oxygen is there, right? So that's where there will be formation of a cyclic compound. There will be formation of a cyclic intermediate which can be called as its general name as ozonide. With general name as ozonide. Okay. So ethene is going to react with ozone to form an intermediate called as ozonide. It's not a product, it is a intermediate. Okay. So by using KMnO4 in alkaline medium and cold condition, temperature around 273 Kelvin. Okay, yes, absolutely correct. So it will be with ozone. In detail, I am not going for that one because this was there in your first PU. Once again, I am telling for second PU board exam, you may not be expecting question from this part, but for competitive exam, they have asked. Okay, so that's where we have the ozonoid intermediate. So this ozonoid intermediate will be hydrolyzed in the presence of zinc. It will be hydrolyzed in the presence of the zinc. Fine, and there will be formation of one of the aldehyde, which is the common aldehyde, which will be formed when alkenes will be taken. This type of alkenes will be taken. Okay. Now, when I am talking about hydrolysis, one H will go with this oxygen. So that's where we have the HCHO, that is formaldehyde. That is nothing but formaldehyde. What can be the another product? One is formaldehyde. That is because this one bond, these two bond has been cleaved. HCHO. That's where there is a formation of formaldehyde. What is that next? Another product which can be formed. Any one of you? Yes, it will be formaldehyde only. It will be formaldehyde only because we have taken the ethene. We have taken the ethene. It will be formaldehyde only. Okay. Now, if I increase, all of you have understood this one? Ethene in the presence of ozone, it will form an intermediate called as ozonoid, which will later hydrolyze in the presence of zinc. It will give rise to formaldehyde. 2 molecules of formaldehyde. Okay. So hagadre next one. Okay, side product in organic chemistry we are not considering. Okay. So next one. if I change the molecule, that's where you will be expecting the question from this particular part. So that's where we are going to expect the question, type of product. In competitive exam, they will ask which product will be formed. Okay, na? They will give the options and you have to take appropriate product. Now I will increase the number of carbon. Now I am increasing the number of carbon. Okay. So I have increased the number of carbon. Now what will happen? Ozonoid formation will happen. And always double bond containing carbons will be involved in the cyclic structure. Okay, AG has given already answer. So don't feel bad. Okay, so I am calling you as AG because it's very easy to call with that one. Okay, so don't feel bad. Now, Arpit has told product itself. So always remember that wherever double bond is there, only those two carbon will be involved in the formation of intermediate. Yes, Arpit. Okay, so that's where we have CH3, CH, CH2, oxygen, oxygen, and once again ozonoid has been formed. Which is this molecule? This molecule is nothing but propene. This is nothing but propene. Okay? So ozonoid formation. Now, as AG has told, Arpit has told, naturally the product will be, one of the product will be formaldehyde. One of the product will be formaldehyde. So what will be the another product? As he has written, ethanol. CH3, CHO. So that's where ethanol, methanol. Methanol is nothing but formaldehyde. So that's where we have the methanol or ethanol as the product. Okay? All of you have understood? So depending on the alkene, a type of alkene, product is going to change. But methanol is constant because this bond is going to get cleaved always and it will get converted into methanol, a constant product. But other part, it will going to be changed. Fine? Any doubts? Now, if you observe, whatever we have discussed, it is only with respect to aldehydes. Whether ketones cannot be synthesized by this method? Yes, we can synthesize. Ketones can be synthesized by this particular method, no doubt. Can any one of you tell me, if I want a ketone, which type of initial alkenes I should take? So whatever alkenes you have observed, what was the speciality of those alkenes? Any one of you? What was the speciality of those alkenes? With respect to their structure I am talking about. Okay. Arpit, very good answer. Secondary alkenes. Very good. Or I can tell unbranched alkenes. Whatever I have taken, it was unbranched alkenes. Okay? Especially at double bond position, there was no branching. And we can call it as secondary alkenes. Now when I am talking about ketones, which type of alkenes I should take? Indirectly I have given the answer actually. Which type of alkenes I should take? Secondary or branched? Okay. So we should take the secondary or branched. Fine. So in that case, CH3, C, CH3, double bond, CH2. Whether it is a branched one, right? It is a branched one, where this carbon is not attached with any of the hydrogen. Where unsaturation is there, one carbon, middle carbon, in this case, middle carbon is not attached with any of the hydrogen. So that's where there is a branch formation. So please remember, in competitive exams, if they give these type of question, observe that if there is a carbon with unsaturation, if it is not having any hydrogen with it, it is going to give rise to ketones. Without any hesitation, you can give the answer. It will give rise to ketones. Okay? So as one of the product. As one of the product. Naturally, there will be formation of ozonoid. There will be formation of ozonoid. Right? Now, which are those two carbon involved in the formation of ozonoid? So once again, naturally, these two carbon. So that's where oxygen, then CH2, oxygen, oxygen, oxygen. So that's where we have the ozonoid formation. That's where we have the ozonoid formation. Right? Arpit? That's where we have the ozonoid formation. Now what has happened? We have taken a alkene where one of the carbon, naturally it cannot be a terminal one, it should be between carbons only, cannot be a terminal carbon. So this carbon is not having any hydrogen attached to it. Okay? So that's where we have taken the branched alkenes. Where the branch is there? Exactly to that carbon which is involved in the unsaturation. That's where the branching should be there. So please remember, don't tell that Raghavendra sir has told, so we are going to get the ketones for here also. Right? No. It will be a different scenario. In this case, it is a different scenario because here branching is there to that carbon which is not involved in the unsaturation. It is next to that one. So therefore, in this case, there is a hydrogen is present with respect to this carbon. So naturally, even this will give rise to aldehydes. But I told that branching should be there to that carbon which is involved in the unsaturation. Don't get confused. Okay? So what can be the product then? Any one of you? What can be the product? Can any one of you tell me? Yes, very good. It will be propanone and formaldehyde or methanol. Both of you are correct. Okay? Yes, Brinda, it can be called as acetone because this bond will be cleaved. That's where we are going to get the HCHO. Then this bond will be cleaved. So that's where we are going to get the CH3, CO, CH3. So that's where we have the acetone. This can be called as acetone or propanone. One and all same. Propanone. Acetone is a common name. Propanone is a IPAC name. Now this is nothing but methanol or formaldehyde. One and all same. Or formaldehyde. That means in ozonolysis, one of the product is always constant, which is that. One of the product is always constantly formed, which is that one. Any one of you? Which is that product which is constantly getting formed? Yes, that is nothing but formaldehyde. That is nothing but formaldehyde or methanol. Okay? So one thing you should make sure that when you have seen the question in competitive exam, branching should be with this carbon which is involved in the unsaturation. No other branching can lead to ketone formations. Okay? But Ozonolysis or preparation by ozone using alkenes can be done even for ketones also, even for aldehydes also. Same as that of the alcohol. Only thing is we have to take different forms of alkenes and different forms of alcohol when it comes to aldehydes and ketones. But these precursors, that means alcohols or alkenes, they can be used for the preparation of both aldehydes and ketones. Any doubts? Okay, so in that case we will move to the next one. So preparation of aldehydes and ketones. But to end means you are talking about this one. Yeah, but-to-ene. It will work out. In that case, formaldehyde will not be formed. Yes, in that case, formaldehyde will not be formed. Which can be the product then? It will be ethanol. It will be 2 molecules of ethanol. But always preference will go with the terminal unsaturated molecules, which will be having the unsaturation on the terminal side. Preference will be given with those alkanes. Otherwise, it will be 2 ethanol in this case. So, formaldehyde will not be the product then, because unsaturation is not on the terminal side. It is in the mid of the hydrocarbons. Okay? You got the answer? Brinda, whether I have reached you? Okay. So we will move to the next one. Okay, I will make another correction. When unsaturation is on the terminal, then only the constant product will be formaldehyde. Otherwise, we can have the different aldehydes. But always preference will be given for the unsaturation which is present on the terminal carbon. Okay. So we will move to the next one. Very, very important. Preparation only, but very, very important reaction. Okay. So that is preparation from acyl chloride. Preparation from acyl chloride. Very important. Okay. Acyl chloride. Preparation from acyl chloride. This is called as Rosenmund reduction. This reaction is called as Rosenmund reduction. Very important from your examination point of view. Very important with respect to your examination point of view. Hagadre, in this case, as the name itself it is there is the presence of acyl chloride. So somewhere we have discussed about acyl chloride, where earlier in first PUC also we have discussed. That is with respect to acylation, Friedel-Crafts acylation reaction, right? Yes, Brinda, with respect to acylation process, Friedel-Crafts acylation reaction, same thing, acyl chloride, right? So if I take CH3COCl, acetyl chloride, R with general symbol. Okay, so that's where, yes, it is also called as acid chloride, no doubt. It is also called as acid chloride. Okay, so when this acyl chloride is treated with Rosenmund catalyst, when it is treated with Rosenmund catalyst, what is that Rosenmund catalyst? That Rosenmund catalyst is nothing but palladium on barium sulfate. Palladium on barium sulfate. So that's where we have the PD, barium sulfate. Okay, so barium sulfate. What do you mean by this? That is nothing but palladium on or with barium sulfate. Okay, so which can be called as Rosenmund catalyst. Which can be called as Rosenmund catalyst. Okay, now I will tell that Rosenmund reduction is nothing but hydrogenation reaction. It is nothing but a hydrogenation reaction. It is nothing but hydrogenation reaction. So can you tell me what you mean by hydrogenation? Can any one of you tell me what you mean by hydrogenation? Okay, it's a reduction, fine. But in the name itself it is there. That means addition of hydrogen. That is nothing but addition of hydrogen. Right? So that's where hydrogenation. It's a reduction. Therefore it is called as Rosenmund reduction reaction. From acyl chloride, whatever it is there, it is nothing but Rosenmund reduction reaction. Or simply we can call it as Rosenmund reaction. But in reality it is a reduction. What is that reduction? On what method they are going to reduce? That is by the hydrogenation process. That is by the hydrogenation process. Somewhere you people have studied about hydrogenation. Even in first PU. Where? A very common method.
Formation of alkanes from alkenes.
Okay, formation of alkanes from alkenes. Yes. So that's where unsaturated molecule will be converted into saturated one. Yes. Even Krishna had given the answer and you people are absolutely correct. Preparation of alkanes. Which is that reactant they will be using there? Which is that reactant? One of the reactant is acyl chloride. Which is that another one? Hydrogen. That is hydrogen. There it will be hydrogen with nickel. There it is hydrogen with nickel. Okay? But here nickel will not be used. I will make it very clear. Nickel will not be used. They will be using hydrogen. And the catalyst will be, another one will be palladium, barium sulfate. No nickel, no palladium alone. I will make it very clear. Palladium with barium sulfate. Alone palladium will not be used. I will come to that point. Why it is like that? Why not they will be using nickel as a catalyst? Okay? For hydrogenation, for alkenes to alkane, it was hydrogen with nickel or palladium as the catalyst. But here, alone palladium or alone nickel will not be used. Always it will be palladium with barium sulfate combination. So that's why it is called as Rosenmund catalyst. Okay? So hagadre, what will happen? Naturally, there will be formation of one of the product as hydrochloric acid. That means it will be dissociated, no doubt. Okay? So hydrochloric acid. What will be the another product? Any one of you, what will be the another product? Naturally it should be aldehyde. Yes, very good. It should be respective aldehyde. It should be respective aldehyde. Okay, that's where acyl chloride hydrogenation will give rise to aldehydes, and the reaction is called as Rosenmund reduction reaction. How the reduction is happening? Reduction by addition of hydrogen. That is by hydrogenation process. We have to remember all these words. Okay? So in the examination, they can ask questions with respect to competitive exams. But for board exam, it will be reactions. They will be asking about the reactions. Okay? So that's where we have the Rosenmund reduction reaction. General equation I have written, that is SI chloride. If I go with your textbook one, they have taken benzoyl chloride. They have taken the example of benzoyl chloride. COCl. So not benzyl, it is benzoyl chloride. Spelling very important. OYL, not simply YL. Benzyl chloride, no. It is benzoyl chloride. Okay? Now in the presence of hydrogen and Rosenmund catalyst, that is palladium on barium sulfate. Sulfur, I am writing it small letter. So barium sulfate, it will give rise to now which product? Can you tell me which product will be formed if benzyl chloride is taken? Benzaldehyde, very good. It's going to form the benzaldehyde. Naturally, another product will be HCl. HCl may not be required. As we know, when I am talking about reaction, yes, benzene carbaldehyde, absolutely correct. Or generally benzaldehyde or benzene carbaldehyde. Many students don't get confused. Sir, whether it is benzaldehyde or benzene carbaldehyde, one and all same. Benzene carbaldehyde is the proper IUPAC name, but benzaldehyde is also accepted. Okay? So HCl. HCl may not be required to mention here. If you write, it's not wrong. Because in organic chemistry, only major or main product we are going to mention. Side product, we are not going to mention. Fine, HCl can be written or it may not be written. Anything is fine. So that's where we have the reaction of benzoyl chloride. So Rosenmund reduction, main advantage here is any of the acyl chloride can be used. Any of the acyl chloride can be used, but except formaldehyde cannot be prepared by this particular method. This is an additional one, but you can mention it. For board exam, they will not ask. Formaldehyde will not be prepared or cannot be prepared. It's not possible. That is because of the instability of the formal chloride. Due to the instability of formal chloride. Okay, formal chloride is not stable. So due to this reason, formaldehyde cannot be prepared by this particular method, Rosenmund reduction method. We have to go with either ozonolysis method for the preparation of formaldehyde. This method cannot be used. That is one of the disadvantage of Rosenmund reduction process. All of you have understood. Otherwise, all the other aldehydes can be synthesized by this particular method. Not ketones, I will make it very clear, not ketones. I am talking about aldehydes. Rosenmund reduction method is meant for the preparation of aldehydes. Preparation of aldehydes. Any doubts here? But formaldehyde we cannot prepare by Rosenmund reduction method because instability of the formal chloride. Acyl chloride fine, but formal chloride is unstable. So due to the instability of the reactant, formaldehyde cannot be prepared. Okay, any doubts with regard to this one? All of you have noted this reaction. Shall I remove this? Very important with respect to your board exam and with respect to your competitive exams. Any doubts? I am expecting one question from your side. No doubt, guarantee. Actually, in fact, that question was, I made or I told some points to expect that question from your side in the beginning of this reaction. Question is, yes, now you got the point. Yes, why palladium barium sulfate? Why not the combination of hydrogen or nickel or hydrogen and palladium? Why we are not going with this particular combination? Why only palladium and barium sulfate? That is because all of us we know that they are the heterogeneous catalyst, right? They will be used to provide the surface area. Oh, Archit, very beautiful answer. Yes. So they will provide the surface area for these gaseous reactants. Okay. So that's why we are going with nickel or palladium as the catalyst. But the problem here is when I am using this particular combination, too high amount of hydrogenation will happen. Now we may have alcohol, primary alcohol might be the product, not aldehyde, if you are directly using this combination. So therefore, to decrease the hydrogenation, to control the hydrogenation process, they are using palladium and barium sulfate combination because barium sulfate is not going to provide the surface for the hydrogen gas. They have the small surface areas, and due to that they are going to hinder the palladium. So hydrogenation will happen, but it will be under controlled condition, as Archit has written. Okay, to decrease us the hydrogenation process. So therefore this combination we have to go. Otherwise we might be having the contamination of the alcohol along with the aldehydes. That's where we should appreciate the Rosenmund catalyst. All of you got the point? Any doubts? Okay. So what is that important point we should know with respect to Rosenmund reduction reaction? Those important point is, one is any of the acyl chloride other than the formal chloride. So what is that Rosenmund reduction application? Rosenmund reduction application, Lindlar's reagent if you are using, it will become a different reaction. Here it is Rosenmund reduction reaction. Got my point? So therefore Rosenmund catalyst we are mentioning here. Okay? So Hagadra, what is that one? Here any of the aldehydes will be synthesized. Any of the aldehydes except formaldehyde. That is one thing. And there will be utilization of Rosenmund catalyst. There will be utilization of Rosenmund catalyst. Otherwise, other catalyst can be used. But since we are talking about Rosenmund reduction, we have to talk about Rosenmund catalyst. Okay. So what is that one? That is the combination of palladium and barium sulfate. What else we have to focus here? It is nothing but hydrogenation process. Rosenmund reduction is nothing but hydrogenation process. So these are some of the points you should keep it in your mind. Okay? So therefore, this is a very important reaction with respect to your exam point of view. If you have any doubts, you can ask. Okay. So next one, once again, I should have not removed that. Once again, very, very important reaction. Once again, very, very important reaction. That is nothing but Stephan reaction. That is nothing but Stephan reaction. As we know, in organic chemistry, any reaction which is with the name of the person, any reaction with the name of the person, that will be important. And Rosenmund reduction, Stephan reaction and all, they have asked many times. They have asked many times. When I am talking about this particular molecule, this particular reaction, here it is nothing but conversion of nitriles to aldehydes. Conversion of nitriles to aldehydes. Conversion of nitriles to aldehydes. That's where we have the reaction. Okay, even esters can be used. Even esters can be used. Nitriles to aldehydes. So what do you mean by nitrile? What do you mean by nitrile group? You can just send the symbol. Yes, it is CN, not cyanide, nitrile. Since organic compound we are talking about. Okay, that's where we have the alkyl nitrile. That's where we have the alkyl nitrile. When this particular reagent is treated with, it is treated with SnCl2. What is SnCl2? What is SnCl2? Tin chloride. Okay. I want more appropriate word. If I want to write tin chloride, I should mention Stokes notation. What is the oxidation state of tin? I have to mention. Yes, it is stannous chloride. Very good. It is stannous chloride. If I want to mention as tin chloride, then better to mention the Stokes notation. Okay, so that's where we have the stannous chloride. Oxidation state of tin here is +2. So therefore stannous, like ferrous, ferric, stannic, stannous. Okay, tin can have the multiple oxidation state. Okay, now with stannous chloride, in the presence of acid, that is hydrochloric acid, in the presence of acid, that HCl, hydrochloric acid, now they will be getting converted into aldehydes. But before that, there will be formation of a reactive intermediates. There will be formation of a reactive intermediate. Okay, so that is iminium, alkyl iminium intermediate or alkyl iminium chloride. Since we are going with HCl, acidic condition, now what will happen are CH double bond NH2. Okay, so please remember RCH double bond NH is nothing but alkyl imine. It is nothing but alkyl imine intermediate, or simply we can call it as imine intermediate. Double bond NH is there. Okay? Since here it is NH2 plus, since we are going with acidic condition, this can be the intermediate, that is iminium. That is iminium. It can be in combination with Cl minus. So therefore, iminium chloride, alkyl iminium chloride will be the intermediate. It's not a main product, it is a intermediate. All of you got my part? So why alkyl iminium? Ammonium means what? NH3 is ammonia. But if I write NH4 plus, that means ammonium. Same way, this is imine and this will be iminium. Okay? So therefore, we are going to have, you can mention this one as intermediate or this one as intermediate. Everything is fine. But this will be the more appropriate one. This will be the more appropriate one because we are going with the acidic condition. But if you mention imine as the intermediate, it's not wrong. It's also correct. And I think in your textbook they have gone with this particular intermediate. Anything is fine. Okay? So which on hydrolysis under acidic condition. So straight away we can mention this one as H3O plus. Water with acidic condition, H3O plus. We can mention it as, 1 minute, water. Okay. Yeah, now you can see. H3O plus. That is hydrolysis only, acidic hydrolysis. This is nothing but acidic hydrolysis. Okay. On acid hydrolysis, now they are going to give the product as RCHO respective aldehyde. Another product will be there which will not be required to answer, but what can be the another product? Any one of you? This bond is going to be cleaved. Yes, Krishna has given the answer, that is ammonium chloride. It will be ammonium chloride, Archie. Okay? So it will be ammonium chloride. Another product will be ammonium chloride. Since we are going with the acidic condition, or since we are going with the acid hydrolysis. So this is where we have the Stephan reaction. So what is that Stephan reaction? Stephan reaction is also once again a reduction process. Stephan reaction can be considered as a reduction process. But directly we cannot call it as reduction because there is the addition of oxygen. There is the addition of oxygen. So therefore, in Stephan reaction, what they will do? They will take alkyl nitride. They will treat with the stannous chloride in the presence of HCl, mineral acid. So that's where we are going to have the alkyl iminium chloride as the intermediate molecule. Even you can simply call it as imine. But if you call it as imine, this should be the structure. If I am writing this one, then it should be iminium because positive charge is there. Nitrogen is tetravalent, 2 and 2. So therefore, positive charge. Which on acid hydrolysis, we can simply write it as H3O plus or water under acidic condition because we have taken HCl. Now they will give rise to respective aldehydes and they will be giving rise to ammonium chloride. Ammonium chloride you may mention or it's not compulsory. Writing the ammonium chloride is not compulsory. Okay? So any doubts? That's where we have the Stephan reaction, another important reaction. Anyway, I'll stop here. Tomorrow we will continue. If you have any doubts, you can ask. So which catalyst they are using? Stannous chloride in HCl. Okay, that is the catalyst they are using. Any doubts? Ethers. No? When I told ethers.
Something like
No, I never used the
the
word.
esters.
Okay, esters, yes, esters we can use. Esters we can use. Okay, fine. So tomorrow we'll discuss about what will happen to the esters if you are taking the esters as the reactant. Okay, tomorrow we will do that. Yes, correct. Either we can go with whatever molecule I have discussed, or we can go with the esters, nitriles or esters. Okay, anything is fine. Okay, then thank you. Thank you very much. Take care. Tomorrow we will continue. So practice these reactions. They are very important. Fine? Thank you. Take care. Bye. Okay.